Yeah, so 3, 2, 1, I'm admitting people.
Hello everyone.
Hi guys.
Hi,
Hey
Prasad.
Madhu. Hi Varnish. Hey Shrikant. All right, let's get our cameras on so we can see each other. Hey Praveen, how are you doing? Hi Durga Rao. Hi Pankaj. Hey Shrikar. Good, awesome. Let's keep the cameras on so that we can see each other and we can get started. So this one is going to be a really fun session. Hey Sharon, long time no see.
Hey Prasad, how are you?
Yeah, where have you been?
Actually, just some quick updates regarding my project. So I have been asked to extend on the project, and I have additional responsibilities now till next year because the
Okay.
client supposedly liked my work. Fingers crossed. So additional responsibilities. But
Awesome.
I'm in touch with Saurabh whenever possible, and every weekend I catch up with the research workshop. So going good.
Good. Awesome. Cool. Hey Shiva. And let's see, Abhimanyu is very blurred. Hi Vedanta. So I'd like to say hi to everybody that switches on their cameras. All right, awesome. So we have a good number. Let's get started and we can go through the session. But this is the first in a series of sessions where we're looking at a couple of different things, right? The first thing is we're looking at new technology and we're breaking it down. Okay. What does that mean is we are looking at any time a new technology is introduced in the market or in our workplaces, it affects us in two ways. One is the kind of work we do, the kind of responsibilities or the role that we do. There's always a job description change to accommodate for the new technology. And there is also new opportunities that come along with that. And the second aspect is it also changes the way we work as well, right? It affects our job as well in a way. So we are going to be covering both of those topics as part of this session. And we'll be kind of trying to understand what this new technology means and how we expect it to work. So with that said, let's get going. All right. So again, for those of you that are new as part of this, we want to just very quickly share, we are a community of designers and we are an industry-run design program. What that basically means is the intention for this program is majorly kind of supported and funded by the industry consortium that we are a part of. And the way it works is, we build a community and we make it as accessible to people as possible. And then, together as a community, we kind of help you learn new topics, new ideas, and then kind of make it available to you. So, and the final goal, of course, is to help you build up those rock star careers. So let's go on to the next one. All right. Rules and guidelines, as always, number one, we are a safe environment. So there is no bad question or a good question. Every question is a good question. So, we don't judge. Whatever questions you have, whatever it is, our intention is to help you grow in your career and we will answer them as much as possible. Participate and contribute actively. So this only works when, one reason, just so for those of you that are new is, for those of you that say, hey, can I have a video recording? We do not give video recordings. And the reason we do not give video recordings is we say, if we just share video recordings, how are we different from, say, YouTube? Because YouTube, you just see recorded videos. Well, the point being is we want everybody to be here in person, so they are seeing the content, reacting to it in real time, and contributing to the knowledge and the discussion that is happening. So that is one thing that we expect all of you to do, is participate and contribute actively. And that also means keeping your cameras on, because we don't get to see a lot of you in person. So it's great to kind of have the camera. So if you have a question or a doubt, I generally see the camera feeds and I kind of see, okay, are people understanding or not? So that helps me get there. Be kind and courteous to everyone, be welcoming and nice to everyone, respect people's privacies, keep your cameras on for the best engagement. And of course, as a community, if you believe that this workshop has been valuable to you, help us spread the word. We will share more information at the end of the workshop. And of course, be present in person, because that's the best way to learn. All right. If there are any questions, just type it in. Otherwise, I'm going to go on to the next slide. Let's go on, Sarah. So a number of you are on a certification track. So this is also a first for us, where, for those of you that have opted in for a certification track, we just expect you to be on, be present actively for the 3 days and contribute. Submit your homeworks on time. And if you're delayed in your submissions, then we cannot actually grade them for a certificate. So make sure that whatever the timeline has been posted, you are posting it before that time. All right. If there are any questions or thoughts, you can ask. Otherwise, we'll go on to the next one. Let's go on to the next one. All right. So today, for this session, we are going to be talking about AI, UX design for AI, right? Using user personas, journey maps, not sure how we do that. I think that's probably like a mistake in creating the deck. But day one, we are going to be talking about what is an AI, how does it work, and we will understand the different modalities of AI, how AIs work. Day two, we will talk about how do you design for an AI, or with, keeping in mind that an AI is probably going to be, be implemented. And then the day three is primarily, if you had AI tools and you had to execute your work, how would you kind of work? So we'll be talking about all three of these on the 3 days. Any questions or thoughts? I'm just going to do a quick stop and then see if there's any questions. If there are no questions, just type in no question and you can continue on. All right. Awesome. Cool. Let's go on to the next slide. So the question that always comes in is, well, there's a new technology, and this is the interesting part, is when we started, UXReactor, we did not really have as many, new technologies. I mean, primarily it was web, and mobile was big. That was about the time when 1+1 was coming out. So just to give you a sense of, history. And that was pretty much it. And we were thinking, yeah, web and mobile, we're going to design for it. Within 12 to 18 months, literally, we had wearable devices. Apple Watch came out, and then, a whole new, session around wearable devices started. Within 12 months around that, we had IoT. So didn't even have a screen. So how you're designing for screens. Within, I think, 12 months after that, we had AI and machine learning that came out. After that, we got, augmented reality. Then we got virtual reality. So literally, the technologies were coming in, and they still are coming in. Every 12 months, you have new technologies that are marching out, right? And if you as a designer have to sit in there and we have to give you, and you want to learn each of these technologies, it is not practically possible for you to learn fast enough to keep up with the technology. So what we are basically doing is, we are saying there's a framework that you have to leverage whenever you get a new technology. First thing that you need to do is understand the new technology, understand what it's good for, what it's not good for, and then you kind of, understand the limitations, the capabilities, right? Once you understand, then you basically need to understand what are the opportunities that are likely to be caused because of that new technology, and what are the new constraints. As a designer, what are the limitations that you'll have to play with, right? And then finally, you create a new strategy for that new technology. So that is the simple thing that you do every time a new technology is incorporated. And that's pretty much what we do, because a lot of times, we've had IoT projects when IoT was just considered like a brand new fad, right? And we still have to execute on IoT within the time frame. So again, that is where our challenge comes in. So this is what this is exactly the same process we follow as we start incorporating these new technologies. So let's go on to the next slide. So quick question for everybody, and feel free to unmute yourself and react back to this. But, what is learning? How would you define learning? And we could probably stop sharing the deck, and then we could just have a conversation. What do you think learning is? Go ahead, Anup.
So, simply, if I answer the question, it is understanding something unknown that may be valuable or means non-valuable at first, but the major part is we always want to understand or learn those are valuable.
So are you saying that understanding is a critical component of learning then?
Yes, it is.
Okay. So understanding why something works and then being able to use that component of understanding to improve something. Is that right?
Yeah, means if I elaborate it, I may go ahead and learn mechanics, but honestly, I may go and start taking courses, but since I am not understanding the part, that doesn't come as a learning. It will be simply going through and watching just like a YouTube videos.
Interesting. So understanding is essentially critical for learning then. Without understanding, you cannot have learning.
Yeah.
Cool. Okay. That's an interesting perspective. Anybody else? And remember Anup's thoughts here, because we're going to have, what he said is actually going to be critical to our understanding of what AI is. So who's next? Yeah, go ahead, Raj.
I think understanding is critical, but then I think the application of it in varied ways is the part where learning actually evolves or revolves around things, is how I see it.
Okay. So what does that mean? It is the ability to apply your understanding. Is that what it is?
I think it is not just the application in a mimicking sort of way, but I think application probably cross-platform or regardless of the same context, or just trying it out. I think just trying a certain process also counts as learning. Like what you'll get out of it is going to be a learning outcome altogether different.
Got it. So what I'm hearing is understanding necessary or not necessary?
Understanding is necessary.
Okay, understanding is necessary, but in addition to understanding, you should be able to take what you have learned in one domain and apply it to other domains. Is that right?
You can explore domains which will help you understand it better, or you may learn something different out of it.
Got it. Got it. Cool. All right. So I have a dog, and I train my dog to, sit, stand, bark, shake hands. Is my dog learning?
Yeah, I think so. He or she is learning.
but there is no understanding. My dog has no understanding.
Means she understands you, means your commands. That's why she is obeying you or reacting to your actions.
Actually, no. She comprehends my commands, right? But she doesn't. Comprehension and understanding are two separate things, right? So if I say sit, she understands that word sit somehow means that you have to, bend your hind legs and then you have to put your butt on the ground. That's what she thinks sit is.
But
Right?
but overall, the process, means the explanation that you gave, means until and unless the dog cannot understand what you are trying to say or what you spoke, so means how can she react to it?
So you're telling me then understanding has different dimensions to it then. So for example, for you, if I am saying, let's say, boil the water, okay, your understanding is different because you're saying, okay, boil the water means I need to get a pan, I need to get water in it, I need to have a stove, and I need to heat it to a certain temperature. So those are all things that you know, right? So you understand the term boil in its real meaning, right? So, or if I ask you to sit down, right, you probably understand, okay, why is this person asking me to sit down? So you probably expect, okay, the conversation is going to go long, or the person is thinking I'm uncomfortable, they're asking me to sit. There's a lot of these different thoughts that are going on. That's what you're understanding, right? My dog doesn't understand all of that. So all I say is sit. She sits. She doesn't understand, right? She doesn't understand why she needs to sit to eat food, right? Or to get a treat. Right? But her understanding is the way I sit is I move my hind legs, I sit down. So there's two completely separate types of understanding there. Which understanding is necessary, or are both understanding necessary?
I guess both understandings are necessary. Understanding in a whole is necessary.
So then my dog is not learning. All right, go ahead, Ashutosh. I'll just leave that. We'll come back here. So go ahead, Ashutosh. You're on mute.
Hello, sir.
Yeah,
Okay,
go
sir.
ahead.
Learning means, I think, from your example, that knowing something and responding to it. Understanding maybe not as much as important in learning. I think that.
Okay. So you're saying understanding, then the new definition of learning is that you don't necessarily need understanding, but
No,
given
sir.
an action, you need to, or given some input, you need to be able to give some output. Is that right?
Yes, sir. Yes, sir.
Okay.
Understanding is critical part, but it is not necessary.
Okay. It is, okay. So it's good to have, but not necessary. What you need is the outcome. That is what
Yes, sir.
you get. All right, cool. So that's an interesting variation. I can buy that. But, again, if anybody has an argument around that, like, feel free to put it out. Go ahead, Praveen.
So learning can be, if in the present you are using any of your senses and you are trying to assist that information, basically, that can be a learning and making a decision over it.
Okay. So let me actually talk to you about a different use case. Okay.
Okay.
How many of you felt that there is something called a sixth sense? We all have a sixth sense, right?
Yeah.
Where something's going to happen and it happens. So generally, for example, if you're riding a motorcycle, you just close your eyes and something hits your eye. You don't even realize that something was going to hit. How many of you have had that happen to you in your life? Right. So was that sixth sense? Was that like, do you believe that that was a sixth sense or that was something else?
Yeah, I think it is based on our past experience. We assume that that is one of the criteria we thought. For example, this place, if you ride a bike very fast, you might thought there might be some accident, might be getting some accident, something like. So based on past experience, we get some sense. That might be a sixth sense.
Yeah, but in this case, how would any past experience prepare you to close your eye at exactly the same moment that something hit your eyelid?
Something like
usually the fear.
Yeah.
Fear makes you close your eyes sometimes if you are seeing
So
something.
technically, then you will never be able to open your eye when you're sitting on a motorcycle then.
If you are sitting on a motorcycle, it not necessarily means that you are fearing all the time.
Sir, I think we subconsciously responding to that thinking.
So is that learning then? So this is very fascinating. So very close to where I live is a city called Dayton, Ohio, where this gentleman, Gary Klein, lives there, right? And he is actually considered a pioneer in this field, where he studies what intuition is, right? And his specialization is looking at people who are, let's say, Air Force pilots or firefighters, and notice how they make these split-second decisions without thinking about it, right?
Yes.
And one of the things that he has is, he calls this what he call recognition prime decision making. Okay. What recognition? There's a cognitive component of you. There's a part of your brain that actually looks at something, evaluates everything, and says, okay, I'm going to make decision A or decision B. For example, you go to a store, you want to buy 2 pieces of bread. There's a part of you that's evaluating the pricing, the weight, the ingredients, and all of that, and choosing A or B, right? But what Gary Klein's thing is, there is a set of decisions that you make very, very quickly, that you're not even aware of why you make those decisions, right? Something as simple as maintaining your balance. When you're walking, not all the ground is even, but you're still maintaining your balance. You're not thinking about it, right? But you've learned to walk, right? And the point being is, what he said is, your brain evaluates all the previous history of how some things work, right? And it then creates a correlation between activity A and an outcome B, right? And these are things you're not even aware of. So if you had to teach a child how to maintain their balance, something as fundamental as maintaining your balance, you would not be able to explain it. And you've been doing it all your life, most of your life, in fact, except for the first initial like 10 to 18 months, you would not have walked. But after that, you've been walking all your life, right? And you still cannot explain how it works. And so what Gary's thing is, if a firefighter is standing on a roof, okay, and this person suddenly feels that the roof is going to collapse and tells everybody to get off the roof in a split second, this person, the principle behind that is, this person has spent thousands of hours on roofs trying to set off the, put out fires. And so unconsciously, his body has processed thousands of signals that are coming. And then his body has prioritized, or his brain has prioritized of those 1,000. These are the 5 signals that are most important for me. And when a signal comes at the right frequency or the amplitude or whatever, at the right time, this person's feeling, the emotional reaction is very, very quick, right? So he feels like the stomach is falling, something is very wrong, and they just don't know why. Something is wrong. And they just tell everybody get off the roof, and everybody gets off the roof, and the thing collapses, right? That is also learning, right? And so I think it comes back to, I think there was a comment that was made by, Surya, that says learning means knowing how to do, whereas understanding means knowing how to work. I could actually buy that, right? That is fundamentally a huge difference, right? So learning is simply how to execute on something, right? Whether how I teach you is different, but understanding gives you a larger sense. It's able to help, it will help you connect to a lot of different things, right? So for those of you that said, you can go to different domains, that's understanding. You cannot go to different domains unless you understand, right? But learning is something much more basic than that. All right. Now, with that in mind, let's continue on with the presentation. Right? So the core requirements of learning that you have is you need to have a problem, a context in which you're applying that learning. Okay. You need to have some kind of an action and you need to have some kind of an outcome. Every learning cycle consists of these three elements. Okay. You have a problem, you take an action and you get an outcome. Or you have a problem, somebody else takes an action and you see an outcome. Right? You're still learning from observing people, right? So these are the three components that you have. Right? Now, how do you learn? Right? So how does a child learn when they're learning to walk? Well, they stand up, okay? They take 2 or 3 steps and their body is kind of getting a lot of signals about their center of gravity and everything else, and they fall down. Falling down is an outcome, right? And falling down is a positive or a negative feedback that kind of goes back and it either reinforces a certain behavior or it makes people say, okay, this is bad, you don't want to do this, right? And you go through that cycle. Same process goes in for my dog as well. When I'm training my dog, if I'm telling my dog to go sit, right? My dog doesn't sit, so she doesn't get any rewards. The moment she sits, she gets a reward. She's positively reinforced and says, okay, yep, now I know what to do, right? Or, for example, if my child is trying to put a finger in the plug, right? I scream at her and I say, don't do it, right? Now she's been negatively reinforced. She knows not to do that because she knows that something unpleasant is going to happen, right? So in all of these cases, when you see there is a problem, there's a context in which something is happening. So in my dog's case, I'm basically telling her sit. And so there is a context, and then there is and there is a certain kind of an environment where I'm sitting, I'm looking at the dog. So all that stuff is happening. And then there is an action that I'm making the dog do. And then there is an outcome. I'm positively or negatively reinforcing my dog, right? So all learning incorporates these elements, whether it's machine learning, human learning, animal learning, whatever it is, every sort of learning incorporates these three things. Any questions or thoughts at this point? Ashutosh, you have a comment or a question, or you just forgot to put your hand down? All right. If you have no questions, we'll continue on because this is the crux of all learning. So make sure that you understand this concept. Everybody clear? Just if you're clear, just type in clear so I know.
So
Awesome. Okay, now let's go on to the next one.
hey Prasad, sorry, but
Yeah,
yeah.
go ahead, Shrikar.
So when we're talking of action, is it only for the physical action?
No.
No.
Right.
Okay.
It could be something else as well. So let's actually think about it, right? Doesn't necessarily have to be a physical action. It could be a thought that comes in as well.
Right.
Right.
Because,
so yeah, go ahead.
Yeah, because I can see and observe something and I can learn as well, right? Without any physical action.
No, so that is a different kind of a learning where you are observing somebody else's action and you're correlating that action to an outcome.
Right.
It doesn't have to be your own action.
Mm.
Right.
Okay.
Or a simple thing is, let's see. You see somebody spilling oil. Okay. And now somebody else has to clean it. You know that if you spill, cleaning has to be done. Right? There's an action and an outcome that happens. Right? And the outcome is, depending on how you look at it, oh, that's hard work, that's wasted oil, whatever. So it's a positive or a negative outcome that you assign to it.
Right. Got it.
So you can learn through observation as well, but the elements are still there.
Right.
Cool?
Cool. Got it.
Okay. Awesome. So let's go on to the next slide. Okay. So now there are two kinds of learning. All right. Fundamentally, there is a supervised learning and there's an unsupervised learning. Okay. And the difference between that is this, right? So supervised learning is the problem and the limits are clearly, very, very clearly defined, right? And the actions to solve the problem and the outcomes are also very clearly defined, right? And this is actually, what I say is search engines are probably one of the most complex pieces of technology that you will see anywhere in the world, all right? And the reason is very simple, and this also underpins why two companies fought and only one won, which is there's a competition between Google and Yahoo to win the search battle, right? And Google ended up winning the search wars, right? And when you look at that war and you say, okay, why did they win? Both of them had two different approaches to machine learning, right? Yahoo was primarily a supervised learning kind of a model, where Google was an unsupervised learning kind of a model, right? And the AI with Google was so much more powerful than Yahoo that at the end of the day, Yahoo couldn't even touch it, right? And I'll kind of run through the difference between that, okay? So in a supervised learning model, what happens is you give a data set, okay? And you say, this is the data set, and here's A, B, these are the variables, right? So this person is 6 feet tall, is white in color, has, blue eyes, black hair, blah, 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 blah. And therefore this person is considered white, right? And so you give a lot of example cases, and then you give the outcomes. And so what the software is basically doing is it's looking at all the example cases that you've given to it. It's looking at the outcome, and it's looking at all the parameters, and it's deciding, okay, yeah, based on these parameters, this is success, right? And you have defined the success, all right? Now, the challenge with that is the kind of data that you create. And the beauty of it is, the benefit of it is very, very fast to train such a data set, right? Because you control the data, you control the positive and negative examples, you're able to give it. That's great, right? Now the negative in that is, it's always limited by your data set, right? If an unknown event happens, the software will not be able to track it, right? Or the software is not that flexible for new cases, right? And so you're constantly having to worry about what kind of data I'm feeding and then how I'm evaluating it, right? So this is the equivalent of telling my child that, okay, so you have to do this, and this, and then you will get that. So my child is just following the checklist and it happens, right? Now, unsupervised learning is a different way of looking at it, right? Where you don't actually define anything, right? You don't define the inputs, right? Inputs could be anything, right? And you are basically saying you don't even know what the actions are going to be, but you're going to say these are the possible actions that can happen. And then you basically say, okay, this was a positive or a negative action based on some kind of criteria, okay? So the software is always learning, right? And so it doesn't have a list. And so it just basically is looking at all the data with like very fresh eyes and is basically saying, okay, people came in, they clicked here, they went, okay, this is positive. A click is positive. People came in, they just saw this and they spent this much time and they left. Okay, spending time is also positive, right? So system is trying to figure out, the actions, it is trying to figure out the outcomes, and or one of those or both of those. And it's basically working in an unsupervised mode where it's constantly learning and its algorithm is basically evolving. Okay, so that's fundamentally the difference between Yahoo and Google. At Yahoo, what we were doing was we were literally having like 1,000 people sit down, look at the searches and say, this is a good result, this is a bad result, good result, bad result, good result, bad result. And you're feeding it to an AI. And the AI was only learning what a human being was saying was good or bad. Okay, based on just somebody being given like $40,000 or $50,000 to evaluate whether something is good or bad. Okay, whereas Google, what it was doing was it was just given 256 colors and say randomly test all these colors, and then my final metric is click-through rate and the time to first click. And so they're basically looking at all of these colors. The AI is constantly changing, and it automatically figured out that X color is better than Y color, and then it just changed the color automatically. Right? So there is no human in the loop as such. It's just the data that's teaching it. So that's a fundamental difference between supervised and unsupervised. So unsupervised learning again, is much more complex, requires a lot more data, and it requires it also plays with a lot more ambiguity. But by the time it is ready, it is very, very robust. All right. Everybody clear with these two types of learning? If you're clear, just type in clear. Cool. All right. So now let's go on to the next slide. All right. So when you look at AI, it kind of progressed in these different forms, right? And again, it's never, again, I'm not saying statistical correlation is outdated and you don't do it anymore. You do it when you think it's appropriate, right? It's just that the technologies have evolved because the problems have evolved. And so when you're talking the earliest way it used to happen was statistical correlation, where what you would do is you would say, the funny joke would be like, oh yeah, if you put Aishwarya Rai on the Yahoo homepage at say 5 p.m. in the evening, your click-throughs are going to go through the roof, right? Well, the reason is that's when India is waking up, and then of course, that image there's a strong cultural affinity. People will click on it and kind of take it through the roof, right? So what it is somebody basically did a statistical correlation between people sitting in a certain location and which photographs they will click, right? So it's a statistical correlation. It's a basic, simple statistics that happens there. Then, what that is doing is, if you are presenting some kind of data, what is the output? So you are controlling the data, you're controlling the output, you're controlling everything. But very quickly, people realized that, you can't just say like, if as long as I'm deciding on Aishwarya Rai versus Salma Hayek or somebody else, I don't control, like, my rate of experiments is only as much as how many hours I can remain awake and, how many of these hypotheses I can create, right? So then they said, well, what if we gave the computer the freedom to think about, the data itself, right? So we are going to give large data sets. So instead of having just one column, Aishwarya Rai, yes or no, we just basically say that, it's a face is symmetrical, the eyes are blue, the skin is this color, the hair is this color, whatever you have, like you break it down into variables, and then you train the system on all those variables. So then the software can automatically find, if it's not Aishwarya Rai, it can automatically find other faces that will get clicked through, right? So that is when supervised learning came about. So if you go on to the supervised learning component, right, here's what it is. Now, this is a AI model that we created when at UXReactor, where we were basically getting people to play these games, okay? And using the games, we were able to kind of give people scores in terms of how well they could multitask, whether they had deductive reasoning, how good their memory was, and all these different components we were able to multitask, we were able to collect, right? And we just fed all of this into a machine learning algorithm, and we said, okay, tell us which of these people would make good employees for UXReactor, right? It's a simple supervised learning model, right? Now, very quickly, we realized that, this kind of gives us a very good idea about who would make a good design student, but this doesn't give us a good idea about who would make a very competent designer, right? And the reason was simple. There was something that we were missing in these columns, right? And we didn't know what we did not know, right? So that is when you come to the next level, which is the unsupervised learning model, right? Where you don't control how many columns you have. You can have millions of columns, right? For example, in this car, you don't control how big a tree is, how big the branches are. You have no control over all of that, right? You literally also have no control over the speed that other vehicles are going, the kind of signages, none of that stuff you have control, maybe signages to a certain extent, but that's pretty much it, right? And so what is happening in this system is you probably have like 5 or 6 other systems that are plugged in to say, hey, there's a car coming here. So it's helping you recognize a car is coming, or there is a signboard on some place or whatever. And you have all these different systems that are kind of identifying. If you look at the right-hand side, you'll see these systems that are identifying what all these different elements are, right? And somehow the software is trying to figure out which data is relevant, which data is not relevant. This is very similar to what you would see on the firefighter, right? the firefighter is standing on top of the roof, and they are getting thousands of signals in their body, and their brain is trying to figure out of those thousands of signals, which are the top 10, 15, 20 signals I need to focus on that will help me survive, right? And this is exactly what's happening in this case. So in most of these cases, you can't even tell the software, focus on this car or focus on that car. The software will figure out what to focus on, what to ignore and all that. And that's what it's learning in real time. All right. So everybody understand the difference between supervised and unsupervised now? Right? Because this is going to be the, the trick for everything else that comes afterwards. Cool. Awesome. Now let's go on to the next slide. Okay, Surya, let's go back. What is statistical learning, right? Statistical learning is, it's basically statistical correlation. It's just a function, right? The function is every time, let us say, somebody goes to a store, right? What is the probability that they will buy a chocolate? Right? It literally is a probability function. So if you have 10 times you go into a store, and this is I'm giving it a very simplified way, but in essence, that's what it is. So if you go to a store 10 times and out of that you buy chocolate 6 times, that means your basically likelihood of buying a chocolate is 60%. Right? So that means I can predict 60% of the time that you're going to buy a chocolate. So the correlation is 0.6, right? So that means the correlation between your going to a store, the action, and you doing a certain outcome, which is coming out with a chocolate, is about 60%. Right? Or the thing is, what is the correlation that when you sit in the car, you are going to put the key, sorry, when you sit in the driver's place, you are going to put a key in the car and turn it on. Well, you do it all the time. So that's 100%. So that's 100% correlation. Right? So that means every time, if you have 100% correlation and you had to create a recommender system, we say, well, you're going to your car, do you want to take your key with you? Right? It's 100% correlation, right? Whereas if you're going to a store, you might say, hey, here's chocolate in a much more prominent place, so you can buy it, right? Because it's a 60% correlation. So that's what statistical learning is. Does that answer your question? Yeah. So statistical correlation is always dependent on the past.
History.
Go ahead, Surya. You got it, right? So it's always dependent on past observations. So you have these observations that you are now calculating a probability function, and that is what it is. So that's how you're doing it. So for that, in order to do that, you have to know what action you're observing and what reaction you're observing, right? So in supervised learning, you're basically you still have your outcome, and you still have you have a larger data set, much bigger than what a human being would probably be capable of handling, but it's still a finite data set and you're giving it. Whereas in unsupervised, it's basically infinite on both sides, potentially. All right, cool. Let's go on to the next slide. All right. So then let's actually think about what are the advantages and disadvantages of AI. So can somebody kind of, we can just quickly stop the sharing and very quickly talk through this. What do you think are the advantages and disadvantages of AI? I mean, or maybe a better way is like, what do you think AI is good for and not so good for?
It's good for automation. That's it. It's like a machine, like we have. It's just an advanced sort of machine, as far as my knowledge. I mean,
it's good for automating. So good.
Yeah.
So you're basically able to automate small tasks.
Earlier we were used to automate small tasks. Now even bigger tasks can be automated, like driving and things.
Correct. So the way it automates is when you have a little AI module that can do one small thing, then you plug it into, make it cooperate with other AI modules, then it will do much bigger things. So if you just imagine 10 years ago, it was a big deal that, using machine learning, you can identify whether something is a house or not, or a person or not, right? Today, you are taking all those modules together and you're implementing that in a driving AI, right? So every time you're increasing the complexity of your automation, but you're automating. That's good. All right, go ahead, Madhu.
Yeah, the main thing is like time. So based on the user's time, it is reduce the user's time. At the same time, errors, human errors, it stops. Something like human might errors subconsciously, sometimes unconsciously. But AI, the AI is, if you give a command, it is exactly will do. That is the one thing.
Okay. Actually, that's not true. With AI, that's a very different ballgame altogether. So earlier, when you used to have computers, just the basic computers, which is sequential programming and all that, I tell it A, it's going to give me B. It's never going to change. Okay. But with an AI, if you have an unsupervised learning algorithm that is constantly learning, you have no idea what you're going to get tomorrow. Today it is giving A, tomorrow it might give you C. You have no idea.
Yeah, this is also one of the disadvantages. I thought it may be in a hospitals they use robots, so like doing some operations. So they'll do it will do exact same instead of compared to the human, it will give better results.
Well, yes and no, right? Because the constraints, if you look at a hospital robot, the constraint is the human body, right? So your lungs, your spleen, all your body parts are where they are supposed to be. You cannot change them, right? The amount of force that you can put on those organs is also finite, right?
Yeah.
And so those are the variables that you cannot change, right? But in theory, an AI can possibly take different routes in your body, right? So one way would be like I go through the stomach and go solve a problem. The other ways I can go through the back and solve the problem, or I can go through the top, right? So AI can actually do routing, and routing is actually a big problem when you're doing surgeries, right? And AI in theory can come up with better routing algorithms, right? So the point being is, with an AI, you can actually define these are the parameters that you cannot play with, and these are the parameters you can play with, right?
Yeah.
And therefore, in the areas that it cannot play with, it will be very rigid. In the areas that it can play with, it will definitely it will try to find different solutions for that. Right? Go ahead, Sharon.
From a data analytics point of view, I was thinking that, an AI, as Surya mentioned, it's good with automation. So it really increases your speed when you're trying to analyze a lot of large data sets, as you mentioned. So identifying patterns in that sense is very easy for an AI to do in terms of a very large data set. But the disadvantage is, why are those patterns occurring? That is where I feel we need to step in and we need to understand the reasoning behind it, because we can still better empathize or maybe because of our biasness try to assume that why did this pattern occur or what. So that the AI can give us the result and we can try to understand why is that result coming. This is my understanding.
And that is an interesting thing, right? I don't think it's a problem with the AI. I think it is the demand of the industry in some ways. Because as an industry, the company doesn't care that the AI understands why a problem is happening, but the AI should know, if given A, how to react to that problem, right? And so most of our training capabilities that we focus on training AIs is focused on saying, okay, if you see this, then do this, right? Or solve this problem, right? That's what you're teaching the AI to do. But the point is, the day is not far when somebody will actually say, well, actually take a step back and try to understand why. So, you can also define the why as a context and as an action and a outcome, right? And so again, that is where the AI will learn when it becomes a business necessity. But today it is not a necessity. Therefore, in that sense, in a lot of cases, the human being is like, yeah, you have the context of why something is happening, and therefore it is giving you a larger perspective. So that context is also what you call as understanding, right? Because in what case do you do solution A versus solution B versus solution C comes through understanding, right? Whereas when you have an AI, it is just learning through repetitive behavior, whereas you're learning through context, but both are different styles of learning, right? So that's a really good point. Go ahead. So go ahead, Ashutosh.
Sir, I think in research, exploring unknown will be biggest advantages for AI.
Exploring the unknowns?
And for research purpose, it will be greatest advantages in AI, and the disadvantage will be implementing AI without knowing its effect.
Right. So and again, that's actually true. Is a lot of times when we implement AI, we have no idea what's going to happen.
Yes, sir.
Right. But the advantage is you can run a lot more experiments. You can think of a lot more possibilities. There are cases where AI has found different theoretical possibilities because as a human being, you have certain biases that come in. Whereas with the machine, it will evaluate theoretical possibilities. So a classic example is, in fact, if you are interested in chess, you should just see like AI in human chess, right? And
Yes,
this AI is playing chess like no human being would play, right? It just is like a very weird way of playing the game, but the AI just wins it. It's just it's just a way that nobody had thought about it before.
Yes, sir.
Right. So there's a different way of looking at it. So cool. So let's go on with the presentation. So now that we've had this discussion, we can actually jump in and see what AI is good for and not so good for.
So only one thing that I would like to put across is even earlier, before AI was there on a larger scale, we had sensors. For example, water tap sensor. Like 10 years back, we go to a tap and we just keep our hand there. We used to get water. That was like sensor works because of that sensor. So now we are integrating a better advanced product. We say that we have this AI in this. We can know how much water is being wasted. We can know how many times a person is using it, at what time it is just like we are collecting the data for a better purpose. I mean, the purpose of the mission was to make things easier. Before water tap, it was a mechanical tap. Now, I guess it is just advancement of things happening. But the native part is about we are like giving a brain to a machine. That's it. I guess that's the critical part about it, and it can judge by itself. I guess if the monitoring power, I mean the power to take decisions shouldn't be with the AI, I guess.
I mean, think about it this way, right? If you have an AI that's monitoring your water tank, okay? I mean, the question is what level of power is appropriate, right? So that's a completely different, and I'm glad you're asking these questions because these are the questions that we as designers have to ask each other every day. Right? How much power do I give to an AI? Right? In fact, in day 2, we will be discussing all of that stuff. So, the key question is, okay, the AI is sitting there at the water tank, all right? And it is basically evaluating, okay, is the water tank full or not? And if it's getting to full, it'll shut off the pipes. If it's not getting full, it'll turn it on. Okay. So that's what the AI does. Should the AI have that power? Okay, sure, it can have that power because I don't have the time and the patience to sit in front of a water tank to switch on and switch it off. Good. Okay. Now, let us say the AI is now correlating this data with like a citywide network. Okay. And the city AI is basically saying, okay, I'm not going to give water to everywhere. So initially it used to have like 1,000 pumps running across the city. Now the city AI says, I'm going to use just the same 5 pumps and I'm going to pump water all across the city. Okay. So what that city AI is doing is it is coordinating all the household AIs to say that I will send you water at this time, this time, this time, this time. The human being doesn't need to know. As far as they're concerned, the water is coming 24/7, right? And it's coordinating, and that information is being sent, and using those 5 pumps, the water is pumped. Now, should you automate that or not? Right? Yeah, sure. Let's automate that. I don't see a problem with that because, I'm still getting the water and this is a job I don't want to do, right? Now, suddenly using that AI, I am now able to predict how much workload, how much water you will consume in any given month. And using that, I can then predict that, okay, so, you consume less water or more water. So I'm now making deals. So another AI is coming and making deals with water suppliers, saying that in the month of December, the water consumption goes down. So I'm going to buy less water now. And in month of June, I'm going to buy more water, right? Should I automate that or not? Well, sure, go ahead, automate it. There's nothing wrong, right? But now suddenly using that, all of that data that's available, now a third AI, a fourth AI can come in and say how many people are living in your house, right? And whether that is whether you're living legally or illegally, because I mean, there's a certain consumption pattern. So, or potentially you can say, well, are you growing illegal drugs, marijuana in your house? Possibly AI can detect that, right? Now, what do you do in that case? Do you want that or not? Right? Well, you say definitely not because I don't want them knowing. But the truth is, these three AIs are already collecting all that information. You have no control.
Even to some extent,
right? Once the data is out, you have no control.
Even to some extent, if it says that on an average, a person is using 10 liters water per day, you are using 20 liters, so you will have to pay extra. That might be scenario. So I guess there restrictions has to be there. That has to be.
Yeah, but you can't restrict it because the data that you're using for some purpose by one machine, once the data is gone, it's gone. The software will figure out some other use for it, or you will figure out some other use for it. Right? So that is where the interesting insights are. So on day 2, we are going to have a very interesting exercise that will focus on what does the software know and what does the software not know. Okay. And it will be fun because then it will give you a completely different perspective. But let's keep going with the presentation. All right. So advantages are within AI, you can do, automation because clearly this is one of the Google, Pixel features that's coming out where they're saying you can get rid of people. But here's the interesting thing, right? Earlier there were people, but now there are no people. So does that mean that's how the sea was looking when the people were not there? Not really, right? So that is all fake data. Those pixels are fake, right? Based on some kind of learning that it got there, those pixels are fake. So now one of the biggest challenges is you can automate, you can do deep evaluation of complex data, you can complete those tasks really well, but you don't know what part of that picture is true, what part of that picture is fake, right? This becomes even more important. Let us say if somebody was taking a picture of a crime scene, right? And an AI reconstructed it. What part of the picture was true? What part of the picture was not true? Right? So this is where you have to start thinking. So the advantage is, yeah, it can do all of this really, really well. All right. Now let's go into the disadvantages. Right? Now, this is a huge, huge deal. Right? Now, what people have realized is recommender systems have been around for the last 10, 20, 30 years. Even if you realize you go to, Netflix, one of the things that you do is you don't actually scroll around, right? You might scroll every 10 times you go into Netflix, you might scroll maybe once, right? But majority of the time you're picking up something that everybody else is watching or that's something that's been recommended to you. And funnily enough, this is what it is, there's research studies that show that you are accepting recommendations that you would have not taken before, that you not have done before, right? And a classic example is the insurrection that happened in the US, right? Because there's so many recommender systems that are tuned to you that they are giving you the news that you're likely to read, that everybody is getting different news. Your news is very different from my news, right? You might be getting the news that Trump's election was stolen. I might be getting the news that Trump's election was, he legitimately lost, okay? Both of these are recommended by systems, the same AI, right? But now what is caused as because of that is because we have become passive consumers of information, and that is what the human beings are doing. is we are now getting into these kinds of scenarios where I am basically going and taking over the Capitol, burning flags, taking over, trying to kill my vice president. I'm doing all of that stuff. Imagine that. Right? The most powerful government in the world came down because of an AI. Right? So these are things that have already happened. Now let's go on to the next one. Right? Here's one, Tesla. Right? Now, AI, no matter how much supervised or unsupervised learning you do, if you look at all of Tesla, right, they're probably driving about 1 million miles every hour. Okay, on average. So that is a massive amount of data. That's a massive amount of use cases. But still, about 20% of the time, they're encountering surprises. Right? Now, here's an example of a Tesla that basically saw this trailer rig was parked on a road, and it basically thought it was 3 different motorcycles. And it tried to drive around it. And it basically went under the truck. Right? Now, that's an interesting thing. So the system has no accounting for surprises, because surprise only comes through context, right? And therefore, you're not guaranteed successful outcomes with the way. So always understand that, whatever the AI is expected to do, it may not help you succeed, right? So there is still your need and the machines go. So you have to understand the difference between that. All right. Now let's go on to the next one. Right. Here's one. Right. Facebook was automatically making Obama white. These are algorithms. Right. He's a black president and it's trying to make him white. Now, what's the problem with that? It's actually racist. Right. So it basically goes against. So what is happening is, this is the bias that came into the Facebook thing. The kind of data that you give to the system is what the system is going to take. So for example, this is where minorities always come into play. Okay. If you're looking at minorities, where let's say black people in the US, and this is where how AI is implemented. So there's a US version of the AI, there's an African version of the AI, there's an Indian version of the AI. And these AIs will work in different countries. Okay. So the US version of the AI, where you say black people account for about 18% of the population, you have less than 18% of all pictures are black. So the AI cannot make any decision on that, right? If you look at Indian faces, you're saying less than, say, 2% of the population is Indian, right? So you are automatically having inbuilt biases into these pictures, right? Now, for the Facebook engineers, when they implemented that, it made sense. Yeah, I'm going to have an AI that's going to take care of North America. I'm going to have an AI that's going to take care of South America, all that stuff, right? But what is the difference for North America for faces? What is the correlation? There is no correlation, right? It's an artificial barrier that the engineer put in, because of which you now have racist AIs, right? And this AI is basically telling Obama, you're not allowed to be black, you're allowed to be white. Right? Oh, sorry, it's not Facebook, it's a Face app. So thank you, Saurabh, for reminding me that. But yeah, so these kinds of cases are more and more common. In fact, even Google at one point was accused of being racist, because Google Photos would automatically whiten people. Right? And so this is where you have inbuilt biases and cultural understanding. So cultural understanding of a species, as a human species, we have a different understanding than the AI does. AI doesn't care about culture in some ways, right? And culture is basically what are called implicit rules that you apply within your society, right? And those rules change all the time. So now the AI is not aware of those rules, so obviously it cannot extrapolate. All right. So now let's go on to the next slide.
So one issue with this, one of the major disadvantages happening is also because of the people who are building it. If the team,
absolutely,
if that out of 10 people, if the 8 people belong to a particular community, unconsciously, because of their cultural development and upbringing, they will be biased to some sort of culture and communities. That's
absolutely.
So
absolutely.
If they start building, keeping those things in mind, if they start doing it, if they do AI, for example, Google does it, it can create a havoc for the whole world, might be. So there is
and that's exactly what you saw with with the insurrection, right? Where the people kind of stormed the US Capitol building. That's exactly what it is, because AI was giving different news to different people and created havoc. Even now, if you look at coronavirus, there's still people that believe that if you drink bleach, you will not get coronavirus. There's still people who believe that, right? And it's all thanks to AI, right? So yeah, let's go on to the next one. Yeah, let's go to the next one. So here are basic applications and videos of applications that you can see. I'm going to just quick shut off my video so you can watch these videos. And Saurabh, if you can take the next 3 or 4 slides where you have the examples, that'd be great. But yeah, go ahead.
It could be a game changer for retail. KPI X5's Kid Do shows us artificial intelligence will soon be put to work at Walmart stores around the country.
For a glimpse of the future of retail, we head to Walmart in Milpitas. The company is launching a small army of autonomous scanning robots.
That's a nice one. It's so cool.
It's about 6 feet tall, equipped with an array of lights, cameras, and radar sensors. It goes up and down each aisle on its own, about 2 to 3 miles per hour, scanning the shelves for empty spots and also checks the price tags.
Because the robot uses LiDAR and other video cameras, what it actually sees is very similar to what self-driving cars see.
The three-dimensional world it sees is detailed enough for the algorithm to figure out what's missing and needs restocking. And when an employee standing on a ladder gets in view of the camera, yeah, it'll scan that too.
Do you feel like a proud papa?
Martin Hitch is the chief business officer at Bossa Nova, based in San Francisco, the company that made the robot. He says it's supposed to drive around obstacles and look for alternative routes.
We boxed it in with 4 TV cameras earlier, and it made a decision on the fly as to how to figure out a way around so that it could carry on with its job. That's the most rewarding thing.
The robot can scan an aisle in about 90 seconds. That's a fraction of the time it would take a human to do the same job. It doesn't get bored, distracted, and presumably doesn't make mistakes. The goal? Fewer empty shelves and better selection. Walmart is testing the robot in 50 stores across 4 states.
Wow, so is that taking somebody's job?
It's not taking somebody's job. It's designed to improve the job. Deborah Espinoza is skeptical. She works at San Jose International Airport and says when automated checkout was introduced there, cashiers were laid off.
Walmart says that they are freeing up their associates to provide better customer service. You buy that?
No.
Walmart says it's still too early to say how the robots will impact their workforce.
Because technology changes the types of jobs that we have, but nothing will replace customer service and human interaction and being with other people and being serviced by a human.
In Milpitas, Kit Do, KPI X5.
So when you look at this is an application that's already out there. Now, what is happening as a result of this is, you're having a lot less misplaced items. You're tracking everything wherever it is, right? And here's the interesting part, right? And we will kind of talk about that in the next one, in the next 2 or 3 ones. But let's just keep watching. Let's go to the next one.
It could be a game changer for retail.
Let's try and darken that up a bit with some cloud. Oh, that's wonderful. What if we were to change all that to rock?
Okay, let's click on rock.
You can probably do 2x, that's fine.
Let's try waterfall just by pulling water down from the top there.
Okay.
Or 1.5x.
Let's try and darken up a bit with some cloud. Oh, that's wonderful. What if we were to change all that to rock?
Okay, let's click on rock and we're gonna replace the mountain.
Let's try waterfall just by pulling water down from the top there.
Okay.
Wouldn't it be great if everybody could be an artist? If we could take our ideas and turn them into compelling images? This technology allows us to create a smart paintbrush so that if you wanted to create a new picture, you can just draw the shapes of the objects that you want, and the neural network can then fill in all the details. If we add a water,
So notice the AI is automatically figuring out shadows,
or if we change
right?
the
It's
ground to be covered in
figuring
snow,
out
then it
layers,
knows that the sky also
lighting,
needs to be a
everything,
different color.
textures.
I really think this technology is going to be great for architects, designers, people making virtual worlds to train robots and self-driving cars. The input to this model is something we call a segmentation map. It's like a coloring book picture that describes here's where a tree is, here's where the sky is, here's where the ground is, and it doesn't have any details. And then the neural network is able to fill in all the texture and shadows and the colors based on things that it's learned from a large database of real-world images.
I would like to see a tree reflecting in that pond.
The real advance here is that we're able to synthesize images with a lot more diversity and more fidelity than we were able to in the past. I really think this technology is going to be great for the dreamers of the world.
Let's go to the next one. Now this is going to be closer home. We can just probably do it 2x. Yeah, that's fine. So this is I believe it's a Figma plugin where you literally type in what you want. Done. Instagram has been designed. So literally all of this is AI, right? Now let's go on to the next example. Awesome. So here are 4 examples that you see in sequentially, farthest away from where we are as designers doing robotics in a retail store, all the way to coming to real world coding, right? In fact, the graphics, figuring out the visuals, all of that stuff is being done, right? In fact, if you go to YouTube and search for grid.io, they'll give you demos of how you can how the software is automatically creating websites in real time. Right? Now, there's still significant technical challenges that come in to kind of get this out in the market, but the what you saw with the scenery where people were building the mountains and the trees and the river and all that, that's exactly the same technology that's gone into Google phones today, right? That was a 2-year-old demo, a 3-year-old demo. Today, when you delete people, that's exactly what's happening. You're deleting people, and then the computer's automatically putting in pixels, right? So these technologies are happening across the board, right? In most of these technologies, the bigger challenges are you need to understand the context, you need to understand the challenges of making sure that the data is accurate, right? Making sure that, you are able to kind of achieve the goals that the customer is setting out. So there's like every time there's a little bit of a push to get to the next level, all right? So let's go to the next slide, right? So the key questions that when you think, what does a UX designer do going forward? Because again, this is where these new technologies are coming in, and probably about a year's time, you will start seeing more and more of these in your products, right? You will start seeing plugins for Figma. In fact, there's a bunch of AI plugins already available there. So you'll see a lot more technology coming in. Now your strategy has to change as you start thinking about this. So let's go to the next slide, right? The 2 things that you need to think about from your strategy. How do I design for AI? How does my job change with AI, right? These are the 2 core areas that you need to focus on, all right? Now, any thoughts or any comments at this point? Happy to take them before we go on to the next one. You can stop sharing and then we can. Thoughts, comments? So my question is, how do you think this changes the way you do your job?
Might be UI work, might be lessened.
Sorry?
There would be lesser UI work, visual and UI work, more of, of course, AI can't do the research part of it would be dominating more of visual side, UI side, I guess. I think so. That would be one thing.
Yeah. So right now, all the demos we are seeing are focused primarily on the UI level, right? Creating artifacts, right? So that is where the focus is. So it's like if you can create an artifact, you are able to get to the next level, right? So that means that you as designers are now more focused on the UX level, right? So that's one thing. What else? Go ahead, Madhavra.
Yeah, I think AI can actually improve UX research in taking better decisions and the surveys and the
I think think you're breaking up, Madhara. I think you're breaking up.
Audible now?
Yeah, you are audible now.
AI can actually help us in making better good decisions. It would actually help us in user research.
So that's true, right? AI can help you do better research, but the research, again, drawing context out of that research is really hard, right? So what AI can automate is collecting the data, right? It cannot automate synthesis of data, right? So even within, and I think there's also a unsaid assumption, which is somehow research is not UI, right? Even within research, there's a repetitive work component, and the way I look at UI, UX is UI is the repetitive component of your job, UX is the creative component of your job, right? Even when you do research, collecting the data is a repetitive component, the creative component is synthesizing it and making the decisions, right? When you look at, let's say, visual design, the tool level work is repetitive, the conceptual component is creative, right? So the conceptual component still stays in your hands, right? The repetitive components go out of your hand. You're going to have systems that are going to take over, right? But yes, absolutely. I get that point. Makes sense. Go ahead, Sharan. We can have Sharan and Ashutosh, and then we can go to the next one. Yeah, go ahead, Sharan.
Yeah. Should the question be how do we design for AI, or should the question be how do we design using AI?
I think that's a really good question. It's actually how do you design using AI is the question, right? Because that is a very interesting thing. And that is surprisingly the one thing that most people don't think about is, as more and more AI is being implemented, designers are taking a bigger center stage in figuring out, well, which AI should be implemented where, right? And what AI is appropriate, what AI is not appropriate, right? And so I think using AI is one aspect of it, which is, how are you, there's obviously like, you are using tools to kind of do your work. That's one component. But the second component is, even when you do your designs, what data should you take from which AI and how do you present it? Right? So that's another whole different level of decision making. And that's also funny because, not funny, but interesting, because we always assume that UX design is equal, but turns out like designers who design AIs, right? UX designers who do AI design are a very, very rare breed, right? And you're talking of these guys as like, these guys are the superstars of the industry in some ways, right? They're earning probably like, 4 or 5 times what the average designers earn, right? And that is a huge, huge deal. So designing AI systems is a huge opportunity that is waiting. And again, funding is like flowing like water in that space. And so there are more and more startups that are focused on doing AI work. But again, there's a whole new demand for designers who know AI and who can implement it. So that's right. So does that answer your comment, address your comment, Sharan? Cool. So go ahead, Madhura. Well, actually, I think you forgot to put your hand
Yes,
out.
yes.
Yeah. So go ahead, Ashutosh.
Sir, I think that AI will help in UI design, but it certainly not replace UI designers. Sir, I think because, even a small fact or a research point can change the whole UI design. So I think.
Right. So I don't think we are all talking about replacement. I think that the first reaction that most people get when they see AI systems is they suddenly think, okay, oh wow, what are the jobs for UX designers, right? That's the first reaction. But I think that is not the question. I think the demand for, designers are still going to be there, right?
Yes, sir.
But there is going to be a need for designers to be able to incorporate AI into their workflows, right? That's one thing. And to incorporate the possibility of AIs into their designs themselves, right?
Yes.
So you have to know how to work with AI and how to use AI. So both of those components, you have to be able to incorporate. That's what makes you a designer who's capable of working in that domain.
Yes.
Right? Cool. So let's keep going and presenting. I think we have two or three more slides and then we can close this.
Excuse me, sir.
Yeah, go ahead, Yash.
So in future days, can it from AI, yeah, can it get unemployment for UI designers, sir?
UI designers, absolutely. I think for UI designers, because you're doing the mechanical part of doing design, the risk of redundancy is very high. Right? And you're already seeing that. In fact, if you look at the job descriptions and all that stuff where people are getting hired, they're saying people with at least 2 to 5 years of experience or whatever. And there is a huge push for people who are more on the experience side, right?
Yeah,
But where people are able to think at the UX level, not at the UI level. So definitely we do see that push where AI is automating the UI components of UI aspect of the work.
Okay then. Thanks, sir.
Cool. Yeah. So again, so today we have a fair understanding of what AI is, how it works, how it learns, right? And again, you don't need to be experts at AI. All you need to know is how it works, what it is. You need to know what is supervised learning, unsupervised learning, and then you need to be able to apply that knowledge into the domain. So as long as everybody is clear on this concept, we will have a lot of fun tomorrow where we're talking about how do you design for AI. So if you have AI systems, how do you design screens with AI systems as part of your workflow, right? And we will also be thinking about what inferences can an AI make about you and not make about you. So those are specific skills where you have to learn as a designer, you need to learn what is the implicit knowledge and the explicit knowledge. And then you also need to know how to present that data. When do you present it? How do you present that information? So that is stuff that we will be talking on day 2. And then day 3, we are going to be talking about the tools and components that are available to you as designers that will make your work easier and faster. All right. So does everybody understand what AI is? Just type in yes. If there are no questions, just type in yes. And then we can go on the next slide. Everybody get this? Awesome. Awesome. Cool. Now let's go to the next slide. So now we got homework. All right. So your homework is fairly simple, right? There are lots of YouTube videos. So what we want you to do is identify an implementation of AI from the world around you. Okay. Then what you need to do is you need to document it in terms of what type of AI would it fit under, right? What it is about and how it works, right? So you need to be able to say how you think, whether it's supervised learning or unsupervised learning, how it is learning. That's the key thing that you need to identify. And you also need to list out the challenges and limitations. Okay. Post your insight on the Discord group, UX Design for AI. And that's where you'd go. And your deadline is 2 p.m. Sunday, 5 December. All right. Make sure you do this. And just by doing that, it'll significantly help you. Now, here's a post that Saurabh did, where he basically called out the NVIDIA AI. And then he basically said, they've trained it to take variable inputs. He believes it is not supervised learning. He believes it's unsupervised learning. And then because it's taking infinite number of inputs, but training continuously. So therefore, they're infinite outcomes. And you basically put your thoughts, right? And one of the things that you need to also do is not only are you writing it out, it's also good for you to read at least 2 or 3 other people and comment on their work as well, right? And comment is not like a good stuff. Like, have a discussion, why it is right or why it's wrong and what your thought process is. All right. So that's your homework. And then we'll see you tomorrow then. All right. Is there anything else I'm missing, Saurabh?
No.
Cool. Yep. And by the way, homework for those guys who are on certification track, homework is compulsory, it's mandatory. And all those requirements are mandatory to be met. All right, cool. Chalo then. Thank you very much, guys. See you tomorrow. Bye-bye.